In this video, we're taking a look at the change of base formula for logarithms, and honestly, the change of base formula for logarithms isn't quite as useful given a calculator like Desmos or some of the more advanced calculators that we have access to now. But back then, if you look at some of the basic calculators, they only have log in there and ln, so you'd have to evaluate your logarithm by using the logarithms with either the base of 10 or the base of e. But you couldn't just evaluate a logarithm with any base, like log base 2 of 20. A calculator couldn't do that for you, so you would need to use this change of base formula. And there's also some other uses of the change of base formula, such as the derivative of logarithms. We need to use this formula in order to come up with that derivative rule. And so there are uses for this, and that's what we're going to be using in this section, and it's pretty simple. So if you look at it, they really break it down. Log base b of a, what you could do is log of any base. We'll just use base 10. We'll just call it log of a. So notice on the top you have log of the inside, and on the bottom you put log of whatever the base is. And this quotient here is going to give you the exact same answer as just entering this. So looking at 8.3.1, they want us to evaluate log base 5 of 200 and round to the nearest thousand. Now obviously with Desmos, you can see, like I was saying, some of the nicer calculators, you see it has log base a. We could put log base 5 of 200, and you get 3.292. But what we're going to do is we're going to use the change of base formula like they're asking us to do. So log base 5 of 200. So we're going to rewrite this. So what we're going to do is we're going to put log of 200 on the top over log of 5 on the bottom. Notice the base goes on the bottom. And like I was saying earlier, you could choose any base for this logarithm. We're just going to stick basic, just log, might as well. So in the calculator, I'm going to enter log of 200 divided by log of 5. And you'll see that we get that same exact answer of 3.292. Here's another example. We'll work through this kind of quickly. So we have 3 log base 9 of 1 over 12. And you could, remember we just got done with those rules of exponents, bring that 3 up to the top and make that the exponent. I'm not going to do so. I'm just going to go ahead and put that 3 out in the front on the calculator, so it should be pretty simple. So we'll have log of 1 over 12 over log of 9. And we'll see what this gets us for our answer. So bring up Desmos. And before I put in the logarithm, I'm going to put 3. And then times, we'll put log of 1 divided by 12. And that over log of 9. And this answer will be negative 3.393 because we got a round. Negative, I forgot the negative. And that's it. That's the change of base formula. That's how it works. So pretty simple. You just run it through this rule right here. And we're going to get a little more complicated in the next video.